So, welcome again in the session. And today, in the previous session, we were discussing about skewness and kurtosis, which is the last topic of your block one. Generally, this is asked in theoretical type of questions. So, I am just going to continue with this. Uh, are you people able to see the presentation on the screen?
Ma'am.
Okay. Okay, so in the last session, we studied skewness. Skewness is basically the position of the data when we plot it into a curve or into a graph, basically on x-axis and y-axis. So we get three type of distributed data, and this data set where the mode is more than mean and median is positively skewed data, and where median, mean and mode all lie on a single line, single plane, then that is symmetrical distribution. And where the mean is less than median and mode, that type of graph or that type of data being represented by the graph is negatively skewed. So there are some relative measures also to measure skewness, like Carl Pearson's coefficient, Bowley's coefficient, Callie's coefficient, and measure of skewness on the basis of moments. So let's see the formula for Carl Pearson coefficient. It is simply based on mean and mode, and we all know how to calculate mean, mode, and standard deviation. So with this, you can calculate, this is SKP representing skewness Carl Pearson's, okay? So Carl Pearson's coefficient of skewness is mean minus mode divided by the standard deviation. Now, we can also write it in this manner: mean minus 3 median minus 2 mean. This was the relative empirical relationship which I told you between median, mean, and mode. The formula now becomes like this: thrice of median minus mean divided by standard deviation. So here, the values basically, theoretically, when you calculate, the values can vary between +3 to -3, but it is very rare. Generally, the value for coefficient of skewness for Carl Pearson's lie between +1 and -1. When it is +1, it is positively skewed, and when you have minus, then it is negatively skewed. Then the next one is Bowley's coefficient of skewness. This is based on quartile. The previous one was based on mean, median, and standard deviation, and this is based on quartiles. I have already told you how to calculate quartiles. The simple formula: Q3 minus Q2 minus Q2 minus Q1 divided by Q3 minus Q1. So Q1 is here first quartile, Q2 second quartile, and Q3 is third quartile. Above formula can be converted to this also, because Q2 is your median, right, is always equals to median. So this coefficient for skewness, K and B, Bowley's coefficient, and S is for skewness. Q3 plus Q1 minus twice of median divided by Q3 minus Q1. So the value of coefficient of skewness is 0 for a symmetrical distribution. What was symmetrical distribution? When the mean, median, and mode all lie on a single line. If the value is greater than 0, it is positively skewed, and if the value is less than 0, it is negatively skewed distribution. Then next is Kelly's coefficient of skewness. This is based on percentile. Percentile are the terms which divide the whole data once arranged in ascending order into 10 parts, right? So P1, P2, P3, we got, sorry, basically 100 we get. P1 to P90. And here this coefficient of Kelly's is P90 minus twice of P50 plus P10 divided by P90 minus P10. So P90 is 90 percentile, and then 50 percentile, and then 10 percentile. So percentile basically divides the data into 100 parts. This can also be calculated on the basis of deciles, where we divide it in 10. We have D9 minus 2D5 plus D1 upon D9 minus D1. Or you can use this also, because D5 comes in between, and that is equals to median. So D1 plus D9 minus twice of median upon D9 minus D1. Now the last measure, which is skewness on the basis of moments. Moments can be taken from actual mean also, and from arbitrary origin. Also, let's see what is a moment basically. So first moment about mean is mu1, which is x minus x bar upon n, right? जैसे आप deviation calculate करते थे mean minus के हर term से, और उसका sum करेंगे और n से divide करेंगे. Then second moment is x minus x bar whole square. You just square it and then sum it. Then we have third moment also, and similarly the fourth one. Okay? Now, if you have frequency in the distribution, if that is not your individual series, that is discrete series, then you divide the calculation of the variance or the deviation will be x minus x bar only. But what you have to do after deviating, you have to multiply it with f, which is the frequency of the given item in your data set. So this is how you will calculate your movements when there is discrete series or continuous series. When it is arbitrary origin is generally equals to assumed mean. So you all know what is assumed mean. You just assume a middle number, or the number which you think the mean of will be around the closest to the mean of the complete data set. Then your moments will be like this: x minus a upon n, x minus a, and your final will be f. If you have frequency in distribution, you will use f, and you have to use d, where d is basically x minus a divided by n. So this is how you will calculate. And now you have to convert all those moments into actual moments, right? Because you have taken arbitrary origin or the assumed mean for the calculation. So these are the formulas for converting your assumed moments to actual moments, and then you apply it in the formula, which is like this: mu3 upon mu2 cube, or you can say mu cube upon standard deviation. And there is one more thing, you can calculate skewness on this beta basis also, which is b1 is equals to mu3, which is moment 3 square divided by moment 2 cube. Okay, so this is how you can calculate this skewness on the basis of moments. Now just understand what is kurtosis. Kurtosis is another measure of the shape of the frequency curve. Till now, while skewness defines the asymmetry, kurtosis defines the peak. How peaked will be your data set, right? So suppose there I told you that for normal distribution you generally gets a bell-shaped curve, but this bell-shaped curve can be like this also, and this bell-shaped curve can be like this also. So this analyzing the peaks, right? How peaked is your data is defined under kurtosis. Okay, so let's see the graphs. So this is what the graph of kurtosis measurements. The first, which is normal curve, is known as mesokurtic. Then, if we have the peak higher than the normal curve, it is leptokurtic. And if we have the peak lower than the normal curve, which is denoted by red line over here, it is platykurtic. So these are the three positions: leptokurtic, mesokurtic, and platykurtic, used in kurtosis. So kurtosis is beta 2, written like this. Beta 2 measures kurtosis and is defined like this: mu 1, moment 1 divided by moment 2 whole square. These are generally used in predicting the cases related to stock fluctuations, demand fluctuations, and you can also use this to determine national income fluctuations also. Skewness and kurtosis are generally used. So this is all about your unit block 1, which was data collection and presentation and central tendency. Now, the next thing which I am going to take today is sampling, because so many questions. It is a very important unit, important block, though this is your block 3, but this is very important as per the examination is concerned. So many questions are asked from this sampling. What is sampling? How many types of sample you can draw? What are type 1 errors, type 2 errors? All these things are asked from this. So instead of taking probability, I am just taking this is sampling and hypothesis testing previous to probability. Okay. So, statistical techniques are generally classified into two broad categories. The one is descriptive, and the other one is inferential. Descriptive is basically where you define the collected data, right? What is the characteristic of that particular collected data, which we have simplified in previous cases also. Like you have bar diagrams for that, you have pie charts for that, now you have skewness and kurtosis also for that, where you only describe the statistics, or you make them presentable, or you summarize them and make them presentable, because otherwise it is too complicated and unwidely distributed, and you cannot draw any conclusion from that. So, descriptive statistics deals with collecting, summarizing, and simplifying data. That's it, right? Like if you are studying accounts, if you are the student of commerce, if you have studied accounts, then accounting is basically you what you do, you journalize the transactions into journal entries. That is simple. You are presenting the data, then you summarize it in the ledger, right? You classify it into ledger, giving the names of different accounts. Then you summarize it in a balance sheet or your income statements, right? So that is what you are doing. You are describing the complete data of a company for a particular financial year. So in statistical techniques also, we have descriptive statistics where we describe the data. And then comes the part of inferential statistics, where you can draw conclusion, where you can draw inferences, where you on the basis of those inferences, you can generalize the solution to common problem. Okay, so inferential statistics consists method that are used for drawing inferences, where you can draw some conclusions out of the descriptive data. Now, the totality of observations, right? Whatever the data you have collected to a particular problem, that data is known as population or universe, right? Totality of observation, all the observations which can be drawn, right, from which inferences can be drawn and generalized, that is population or universe, right? Suppose if you are studying the level of satisfaction which people get from vanilla ice cream, right? From consumption of vanilla ice cream of Vadilal company. Then the population for this particular problem will be all the consumers who are consuming that particular ice cream, right? That will be your entire universe. And suppose that universe is of so many, so much in India, it will be in crores basically, because everyone consumes vanilla ice cream. Okay, then what you do for analyzing the satisfaction from this, you cannot study the entire universe or the entire population, right? Then what you do, you just study on 2000 to 5000 people who consumed Vadilal vanilla ice cream. And this, what you do, like studying 2000 to 3000 people only, is sample, right? So, a part of totality on which information is generally collected and analyzed for the purpose of understanding any aspect of population is called a sample. So what is a sample? It is part of the totality or part of the universe on which you perform your actual study, and then you generalize that to entire population. Okay, so this is what a sample is. It is the part of universe only. Now, sciences or samples, sometimes it is possible and practical to examine every person or item in the population we wish to describe. Suppose your study is, we can take the example of this COVID also. In very initial stage, when the vaccine was developed, that vaccine was tested on say 20 to 50 people only, right? These 20 to 50 people will become the sample for that. Okay, and all the people who are or who can come into contact of this COVID-19 will be the population. Why there were always problems and rumors and etc that we should not take COVID vaccine because it is not properly tested and all? Because the sample size for that particular vaccine test was very small, right? So if there is any possibility, right, if there is any possibility to practically examine every person or item in the population, then that is called census. If you can examine or analyze every person or item in the population, then that is sample. But if you are unable to do that because of time constraint or because of the massive amount of work required, you take a sample. Now, the very first thing which should be kept in mind for while choosing a sample must be representative of population. How can that sample be representative of the population which you are going to study? Just understand here, population means your totality of observations. Here, population does not mean corresponding to the living population of any country or world. Okay, so this population is basically totality of observations which you are studying to a particular set of problem. Okay, so what should be the sample? Sample should be the true representative of population. It should be the true representative. How can it truly represent the population? The very first thing, it must be drawn from the population only. The second thing, it must be the size of the sample must be appropriate. It should not be too small that you cannot make a generalization, and it should not be too large that you cannot make the generalization. So the sample should be true representation of population. Then in later slides, I will tell you how to calculate a sample and what will be the true representation for a population. Now, So if population is like this normal bell-shaped curve, then your sample must be drawn considering all these aspects, and it should also be in normal bell-shaped curve. Okay, so let's move on to advantages of sampling. The very first advantage of sampling is timely results, because to study the entire population was very time taking. We generally take a sample and then timely results are drawn from that. Next is more accurate results. Sampling techniques involve inaccuracies owing to sampling errors. But once the sample is drawn with precaution and it is true representative of population, there are always more accurate results. Okay, then it is less cost. Because the size or the respondents of your particular research problem has reduced. It means you will be having more resources available to study, and because of that, the cost consideration in sampling techniques or in studying the sample or analyzing the sample are less as compared to the census method. Then next is your destructive testing. So if in the course of inspection the units are destroyed or affected adversely, then we are left with no option than to resort to sampling, right? For example, test of quality of explosives, right? See, now if we do the test of quality of explosive on all the explosive, then what will be left after that? Nothing. That's why we draw samples for that, because these units are destroyed or affected adversely once the tests are done. Next, used in certain cases where the population is infinite or where the census method is not physically possible, or where the numbers are of the items or the studies constantly changing. They are not permanent in nature, they are constantly changing. Now, these were the merits of sample surveys, but they can only be realized if a sample is drawn in a scientific manner. Scientific manner is basically the method in which the sample should be drawn. It depends on the nature of research which you are doing, in nature of investigation which you are performing, what method or what type of technique you should use to draw a sample. If you have adopted the right technique, the correct method, and correct formula for calculating sample, then yes, all the merits of sampling will be with you, right? Second is the appropriate sampling design is used. There are so many designs available for sampling. In some books these are referred to as sampling techniques also. There is random sampling, quota sampling, geographical location based sampling. So you have to choose as per the research what is more required design for your sample. And the third thing which is required to attain all the advantages is sample size should be adequate. It should be the true representation of the population. Now, there are some situations in which conducting a census is better than taking a sample. And these situations, when the population size is very small, the cost and time required for complete enumeration will be less. And the population is very heterogeneous. It's not of similar kind. Then also you go through that census study, and in case like totaling of cash or income or expenditure etc., accuracy can be achieved only through census. So these were the advantages: facilitating timely results, more accurate results, less cost, destructive testing, and used in certain cases. Are these advantages clear to everyone present over here? And what is sampling, what is population, what is universe, what is census, all these concepts are clear. Just
Yes, ma'am.
okay. Now let's move on to what is sampling design. Definition of sampling design. It is basically method of collecting the sample. It specifies a method for collecting the objects. See, in your books or in many books, this word objects can be used with the values also. You can use the word, there can be the word values or items or observations that contain the required information, and these objects are called generally element. Okay, an element is object or which is on which a measurement is taken, right? The element may occur individually if you are studying an individual, or in groups of population also. In group of element, we just say it to be a sampling unit, right? You can study individually also. Your research can based on individual characteristics also, or in group also, or in communities also. So that is known as sampling unit. It can be individual selection and it can be collection of elements also. So sampling units are non-overlapping collection of elements from the population, like a household community residents or a carton of light bulbs. If you are checking the accuracy of the light bulbs, then you just don't check each and every bulb. So what you do, you just divide those thousands of bulbs into carton of light bulbs, and you just take one bulb out of one carton and do your study. So this is what element is or sampling unit is. We all know what is population or universe. In statistical investigation, we usually study the various characteristics relating to items individuals belong to a particular group. And that particular group of individuals is population or universe. Now, there can be, you should understand one more thing also. If you are doing any market research or you are performing any research, you have to be very particular in that research, in identifying your population or universe. Suppose that research is related to analyzing the investment behavior. You cannot write the topic of your project, of your research, analyzing the investment behavior of, means for of what particular type of people you are analyzing the investment behavior. Now you write analyzing the investment behavior of youth, then you have to define youth also, the particular age category which you are going to define. So analyzing the investment behavior of youth, where youth belongs to the age of 20 to 30 years. Okay, now the population for this study will be the entire youth of 20 to 30 years. Still you cannot perform this study while you take samples also. So now what you have to do, you now again you specify or define your problem and pertain that problem to a particular area. Suppose you are analyzing the investment behavior of youth of Lucknow, right? So this will be the proper definition, and here your population or universe will be all youth from the age of 20 years to 30 years who are the residents in Lucknow, who are the residents of Lucknow. So, this is how you define population or universe, and also indirectly, I told you how to define a research problem. You have to be very particular in defining your research problem. So these three things we studied. Sampling design, it is a method of collecting the sample, element, an object on which measurement is taken, and sampling unit, which is collection of all the elements. Population or universe is group of individual. The next thing which is always there while sampling is bias and errors in sampling. Now, in statistics, the difference between the true value and estimated value is called error. You take an estimate and you actually analyze the data and you get a true value. So, whatever the difference between the true value and estimated value, that will be an error. There are many causes for such deviations between two results. And these causes, these errors in a statistical investigation may be broadly classified into sampling and non-sampling errors, right? So in statistics, we have two types of errors. The one is sampling error and the other one is non-sampling error. And these error occurs these are basically the deviations between the estimated value and the true value or the actual value which you get from your analysis of data set. Now, what is sampling error? The result of sample survey are bound to differ from census results since only a small portion of population is studied in the sample method. These errors are caused due to, if there is sampling error, then fault in selection of sample or faulty selection of a sample. When you don't select a sample as per the nature of the research, right? As per the requirement of the research, then you can get a very high difference between population between your true values and estimated values, and that will be due to a sampling error, faulty selection. Then faulty demarcation of sampling units, right? If you demark sampling units differently, right? Demarcation, the action of fixing the boundary or limits of something. Okay, so if you demark your sampling units in non-productive form or in non-appropriate form, then also the error, and that error is also known as sampling error. Improper use of estimation techniques, right? So standards can also be the problem, right? If you are estimating the results from improper techniques, then also the error is caused or known as sampling error. The variability and heterogeneity of the population to be sampled. If the population which is being studied is very heterogeneous or very variable, then you cannot use sampling technique. Despite of that, if you take out the sample and perform the study, that will be full of sampling errors. Now, the next is non-sampling errors. These arise in all surveys, whether it is a sample survey or a census survey. Such errors arise due to a number of cases, such as defective methods of data collection and tabulation. If you use the wrong method or the defective method for data collection and tabulation, data collection is done through so many sources. I already told you primary sources and secondary sources. Primary sources, in general, we use questionnaire. Suppose that questionnaire is not perfectly designed. You know, in statistics, we have uh, the test to check whether your questionnaire is appropriate or not. The best example to analyze your questionnaire is questionnaires validity, whether it is valid or not, is Cronbach alpha. So there are so many tests for identifying whether the data collection tool which you are using, means your questionnaire, is appropriate or not. Okay, so that is data collection and tabulation or faulty definition. You are defining your data. In the problem which I said, analyzing the investment behavior of youth pertaining to age category 20 years to 30 years in Lucknow, if this definition of youth wasn't there, then that will be faulty definition. Data collected will be more heterogeneous and there will be non-sampling errors. And incomplete coverage of the population. If you don't cover the population or sample completely. Population coverage will be in the study of census, and sample coverage will be in the study of sample. And you don't cover the sample, then of course the results will be filled of errors, and those errors will pertain to non-sampling errors. Now, why these non-sampling errors generally arise? What are the reasons for that? The very first is faulty planning and faulty definitions, which I have already told you. Then next is inaccurate methods of interview or observation with ambiguous schedules and instructions. What is a schedule? The new word over here is schedule. In research, while collecting data, we use questionnaires, okay? Schedule is also a type of questionnaire, but it is used when the respondent is unable to fill the questionnaire on their own. So, schedules are generally filled by the researchers by taking answers from the respondents. Okay. So, the basic difference between questionnaire and schedule is questionnaire is to be filled by respondents themselves, but schedules are to be filled by researchers by interviewing or by asking questions to the respondents. So if you use some inaccurate method of interview or not unambiguous, ambiguous is confusing schedules or instructions, then also your final results can be subjected to non-sampling errors. Next is lack of trained and experienced investigator. If the researchers or the investigators are not trained and experienced to collect data, to analyze data, then also this type of particular, you can say the result will be non-sampling error will be there in your final results. Next is personal bias of the investigator. Can anyone tell me what is personal bias? Do you know biases or personal bias? It's like alarming check whether you people are listening or not. Okay, so I consider silence to be non answering the question. So let's understand what is personal bias. Personal bias are related to favorism of researcher, where researcher uses any kind of favorism in collecting data, and this favorism is affected by emotional and physical health of researcher, emotional and physical health of researcher. So, if that person is not emotionally stable or physically stable, so the results can be affected from the personal bias of the researcher. Next is failure of respondents' memory to recall the events or happenings in the past, where respondents don't, uh, they take less interest, or they think that why I should fill this questionnaire, why I should do this. I don't recall the past things which have happened, right? So that is failure of respondents' memory to recall. And errors committed in data processing operations. When you use data processing operations, then some errors can occur, like deletion of particular data or something like that, and errors during presentation and printing of tabulated results. So these were the non-sampling errors. Now, non-sampling errors can be divided into two parts. The one is field worker errors, you can say the researcher errors, and the other one is the respondent errors. Now, if they can be intentional and unintentional. So intentionally, if a field worker cheat, they just fill the questionnaire and give it to you. Yes, I went there and I got all the answers like that. That will be cheating. And leading respondents, like influencing the answers of the respondents intentionally, that will come under this category. Then unintentional error, interviewer characteristics, which I say personal biases, emotional condition, physical condition, misunderstanding, if you don't understand something and just explain it like heaps and throw, that is what. And the last one is fatigue, where you don't want to do the work, you are so tired. Then comes the respondent part, intentional errors, where falsehoods, they don't disclose the true information, and non-response, they don't even respond. Then next is unintentional errors, same misunderstandings, guessing, game, attention loss, distractions, and fatigue. So these were the non-sampling errors related to the research. Now comes the important part, which is sampling methods. What are the different sampling methods available? So, generally, two methods are there and they are based on probability. If you are using probability, then that is random sampling. And if you are not using probability, then that is non random or judgment sampling. So, in probability,
Excuse me, ma'am.
yes, yes, yes.
Ma'am, can you give one example for personal bias?
Example for personal bias. Okay,
Yes,
suppose
ma'am.
I have to take the results. Suppose if I have to analyze the feedback in my particular class, okay, of all the students of my particular class, and suppose that is basically related to 10 years of teaching. So there will be 10 batches, right, from every year, and I have to collect that data and I have to collect that feedback from that. Then suppose my principal said, okay, you can collect the data from say 500 students, that will be sufficient for that. Then what I do, I will choose my favorite students for that purpose, and the students which I consider were listening to me in my lectures, and I will get that feedback done by them only. So what am I doing? I am using favorism for that particular purpose. So this will be the example for personal bias. And the personal bias can also be in actual researches also. This was just of an example. If you are in the same result in a study, suppose you are doing a pan-India study, means pan India study means you are taking respondents from all over India, but since you are the resident of Uttar Pradesh, your more data is from the residents or the person you know from Uttar Pradesh only, not from Maharashtra or Kerala or South, you can say Gujarat and etc., because you were not able to go there, or you are just filled with fatigue or whatever it is. So this, in this kind of particular example, there will be errors related to personal bias, that yes, I'm taking the analysis, or I'm doing the analysis on the people which are easily available to me or which are known to me. Okay, is this clear now?
Yes, ma'am. Thank you.
Okay. So let's come to probability or random sampling. All the items in the population have a chance for being chosen in the sample. If there are equal chance of every item of being chosen in the sample, and you are doing like that, then that sampling is known as random sampling or probability sampling. And what is non random sampling? When you use your judgment or personal knowledge and opinions to identify the sample, then that is non random sample. In every research, you cannot use probability sampling because of the constraints of environment or because of the constraints of population. Then you go to judgment sampling or non-random sampling. Now, these are the simple methods of sampling: probability or random sampling and non-probability or non-random sampling. It does not mean that you cannot use these sampling methods overlapping to each other. You can do that also. Means first you make judgment, and then if you are making sample out of those judgments, you can use simple random sampling, so they can be overlapping. So in probability or random sampling, we have simple random sampling, systematic sampling, stratified, and cluster, and area, and multi-stage. We will look to these in detail. And in non-probability, we have judgment sampling, convenience sampling, quota sampling, panel sampling, and snowball sampling. Let's move on to each one by one. Simple random sampling selects samples by methods that allow each possible sample to have an equal probability of being selected, have an equal chance of being included in the sample. That is simple random sampling. Now, what are the methods for random sampling? The one is lottery methods, and the other one is use of random numbers, right? Like every 7, 8, 9, just simple random numbers you use from the lot to draw a sample, or you use the lottery method for that. That is simple random sampling. The next is systematic sampling. In this type of sampling, the first unit is selected randomly. The first unit is selected randomly, and then every kth item on the source list is selected, which becomes the part of the sample. Suppose you just choose a student, first student, and what you do here, the second one, and the next what you have done, every third person now from the population. So 1, 2, and 3, the fifth one, then the eighth one, and then the 11th one. So every third person or every seventh person, right? So this is what every kth person if you are taking in your sample. But the very first unit or the very first element is chosen by random selection. Now, stratified random sampling. This design is recommended when the population consists of a heterogeneous groups. Heterogeneous group when two groups show different characteristics. So to use this method, we divide the population into relative homogeneous groups called strata. And out of those strata, we then choose samples. Suppose we have divided this into group 1, group 2, group 3, and group 4, and then we choose a sample, right? We can take the example for that ice cream one only, where we are analyzing the level of satisfaction from vanilla ice cream of the population of Lucknow, suppose. Then we will be having so much of heterogeneous population. We have kids, we have adults, we have old, we have adolescent, we have toddlers. So what we do, we define all those into groups, okay? And then out of those groups, we select sample, and that is strata. The group are known as a strata, and when you select from those groups, that is stratified sampling. Next is cluster sampling. We divide the population into groups or cluster and then select a random sample of these clusters. There is a difference between a stratified and cluster sampling. In a strata, we are collecting individual elements or individual units from groups, while in cluster sampling, we have so many groups that we particularly take groups as sample, okay? Take clusters as sample. So suppose we want to take a sample of 5,000 households from state of Haryana. At first stage, the state may be divided into number of districts, and few districts will be selected on random basis. So this will be your cluster sampling. Just don't get confused in cluster and stratified. In cluster, we randomly choose groups, right? And in strata, we make groups and choose individuals from those groups. Okay. So this is what is your stratified sampling, where we make three groups and we randomly choose people from different groups. That will be your stratified sampling. I can say people also if you are doing research on individuals, and there can be units also if you are doing research on some, say, consumer durables or items. And what is in cluster sampling? You choose an entire group, two or three groups completely for analyzing the data. I think the difference between stratified sampling and cluster sampling is clear from this particular picture. Okay, I consider silence to be yes. Let's move on further. Next is area sampling. If the clusters are divided on geographical basis, then it is termed as area sampling. So, in area sampling, when the clusters, there are clusters, and those clusters are divided on the basis of geographical basis, right? On the basis of their geographical boundaries. In general pan India studies, we form clusters and then do area sampling. Okay. The next is multi-stage sampling. When sampling is done on more than one step, okay, or stages, then that is called multi-stage sampling, where you choose groups, then you choose individuals out of groups, then you make another groups. When the size of population is very large, you have to do multi-stage sampling. And you can use any suitable method which we discussed. The next topic is non-probability sampling, which is judgment sampling. In this method, sampling, the choice of sample items depend exclusively on the judgment of the investigator, right? So whatever the research you are doing, the choice will be of the researcher to choose the sample. There is an example. For example, if a sample of 10 students is to be selected from a class of 60 for analyzing the spending habits of students, the investigator would select 10 students who, in his opinion, are representative of the class. Okay. So this method, though very simple, but it is not scientific. The population units to be sampled may affect the personal prejudice or bias of the investigators. We have more personal bias in non-probability sampling than in probability sampling. The very first example for this type of sampling is convenience sampling. The researcher simply selects the sample or the sampling unit that is easily available and accessible. If you are analyzing investment behavior and you choose Lucknow to be the area of research for your particular study and you reside in Lucknow also, then that will be your convenience sampling. Okay, you are doing analyzing the results based on the convenience. You are drawing samples on the basis of convenience. Then comes the quota. We have studied stratified sampling. When you choose sampling units, you divide them into groups based on your judgment only, and you select, then that is quota sampling, right? So you just assign strata and you choose out of those strata. Then panel sampling. In this method, regular surveys are taken by the researcher from a panel of experts, right? Then suppose if you are doing an analysis upon the national income, and you want to study the growth or the prospects of national income for the country, what you can do, you can make a panel of experts in which there will be some say FMS faculty you can take, or some economics experts you can take, right? And some other people who are working on good positions of policy making in RBI, you can take them. So these will form the panel of expert, and you just make them or request them to fill your questionnaires or schedules, and you do your study. Then that will be panel sample. The panelist may or may not know about others. There is a choice. If you want, your panelists may know each other, and if you don't, they do not know each other during the research process. Snowball sampling. Snowball sampling, this is a method used in cases where the population to be studies is rare. छोटा होता है, कम पॉपुलेशन होता है या रेयर पॉपुलेशन होता है, तब हम स्नोबॉल सैम्पलिंग यूज करते हैं. गुड रिप्रेजेंटेटिव सैम्पलिंग यूनिट्स का हमको अवेलेबल नहीं होता है. सो इन दिस मैथड रिसर्चर इनिशियली सेलेक्ट अ सैम्पल यूनिट based on his judgment, and then starts taking further samples on the basis of directions, advice, referrals of by the first sampling unit. Okay, so suppose you are doing a research on, say, cancer study, skin cancer study. So what you do, you just take a group of doctors, and that will be your first sampling unit, and then ask those doctors to provide references so that data can be drawn, more data can be drawn. So those doctors will provide you references out of that. This is this type of sampling, okay, in which initial sample is selected by your own judgment, and further the references are taken. This technique is known as snowball sampling. This is like this snowball sampling. The first person, you just take a group, then they will refer others, then they will refer others, and you can add on to that. So this is all about sampling. The next and the very most important thing is hypothesis, how to write an hypothesis, or you can say what hypothesis should be the accurate representation of the problem which you are going to study in your research, how these hypotheses are tested, what are the different tests available on the basis of the nature of data, what you can analyze, what test you can apply to test your hypothesis. So let's understand just what is hypothesis, a simple highlight on that, because time is very less, only 2 or 3 minutes are left. So a hypothesis is a proposition which researcher wants to verify, right? So suppose if your research is identifying the level of satisfaction of consuming vanilla ice cream in kids, then the hypothesis which you want to prove will be that kids are highly satisfied with the usage or with the consumption of vanilla ice cream. So this is your proposition which you want to verify, which you want to analyze whether it is true or not. So hypotheses are generally concerned with the causes of a certain phenomena or a relationship between two or more variables under investigation. The research which I mentioned about vanilla ice cream will have so many variables. The first variable will be level of satisfaction. And the next variable will be consumption of vanilla ice cream, how much you are consuming, right? So this is how you will study the relationship between these two or more variables in your study, and the hypothesis will be formed accordingly for these variables, and that will be a proposition which a researcher wants to verify or to check. The next thing, procedure for hypothesis testing, how to choose hypothesis, what are hypotheses, what are type 1 and type 2 errors, how these hypotheses can be tested. All this I will be continuing in the next lecture. I hope this class is I think there are no problems left or something. If you go through these slides and you find any difficulties, you can discuss me in my further sessions also, or like the counseling sessions which are there in the regional center. You can come over there and discuss if you have any problems related to the topic which I have discussed, or related to anything related to your this management program. Thank you very much. Does anyone present over here has any question related to particular today's topic or discussion?
मैम एक्चुअली 20th का क्लास मैंने मिस किया था, तो उसका मैम
Did
रिकॉर्डेड
you
सेशन